In this video, we'll be looking at the perimeter and area of rectangles. When you talk about rectangles, we normally refer to the length as L and the width as W. And often they're considered the length to be the longer and the width to be the shorter, but that's not a hard and fast rule. It's just the length is one side and the width is the other side. When we talk about perimeter, the perimeter formula is easy to imagine because perimeter is just adding up the side lengths, and so since the opposite sides are the same, you've got two lengths and two widths, and so we say the perimeter is 2L plus 2W. And then the area of a rectangle, because a rectangle can be broken into a grid with L units on one side and W units on the other side, all we have to do to find the number of unit squares, which is how you calculate area, is multiply length times width. And so these are our two formulas that we use when talking about rectangles. So our first example says the perimeter of a rectangle is 16. What is the least possible area of the rectangle if the side lengths are whole numbers? So we look up the information given to us, which is the perimeter of a rectangle is 16. Now just knowing the perimeter doesn't tell us what the side lengths are, but it gives us a way to find possibilities. So since perimeter is 2L plus 2W, then we know 2L plus 2W has to equal 16. But to make the problem a lot easier, we can actually divide a 2 by everything and show that length plus width must equal 8. So we think of all the whole number pairs that add up to 8, and so our options are 1 and 7, 2 and 6, 3 and 5, 4 and 4. And we want to find one with the least possible area, which means the least possible product. Well, if you calculate all these products, you get 17, or 7, 12, 15, and 16. And so the least possible product is clearly 7. The greatest was 16. And what you'll find out is you always want to go to the extremes, because the extremes are going to tell you where your answer is. So we either wanted to have the side lengths being furthest apart, like 1 and 7, or closest together, like 4 and 4, which is a square, but a square is considered a rectangle. So our answer is the least possible area of 7. The other example just uses a little bit bigger number. We use 42. And so if we do 42, we do the same trick we started with before, which is if 2L plus 2W equals 42, then we divide everything by 2 to get length plus width equals 21. Now we start considering all the pairs. Well, the problem is our number of pairs is pretty high. And so we start with 1 and 20, and then we look at 2 and 19, and 3 and 18. Well, that's going to start getting take a little while to add up, and so the last one we're going to look up is 10 and 11. Well, the area when the side lengths are 1 and 20 is just 20, 1 times 20. Area here is 38, 3 times 18 is 54, and what's going to happen is it's going to keep getting bigger as the side lengths get closer together. So if we want the greatest possible area, we go to when the side lengths are closest together, which is 10 and 11. And 10 times 11 just is 110. So the rectangle with the greatest area is the one where the side lengths are right next to each other, 10 and 11, and then you multiply those together to get 110.